Let's start with A. Remember, A is being multiplied by sine of x. It is on the outside of the function. And so right now we have a function that just looks like ordinary sine of x, but it's actually a times sine of x where a equals 1. We'll notice multiplying by 1 doesn't actually change anything. As we increase the value of a, we can see we're stretching out the function vertically. It gets taller and taller and taller. And similarly, as we decrease a, we're squishing the function vertically as it gets smaller and smaller and smaller until it's perfectly flat. If a ends up becoming negative, we flip the function across the x-axis, as we can see here. A changes the amplitude of our sinusoidal graph. That is, it tells us how tall the waves are as measured from the middle of the graph. As we can see on this graph, with our blue graph here, a equals 1, because the height of the graph from the middle equals 1. If we change a, let's say we make it twice as big, a equals 2, we'll notice this makes the function twice as tall, and we can draw our graph by taking every point from the blue graph and multiplying it by 2. Now the distance from the middle of the graph all the way up to the top is 2, and we can see that also measured from the middle of the graph to the bottom. That distance is also 2. What's the amplitude of this graph? Well, we can see that it's centered right here at 0, and so we just have to look at the height from the tallest point down to the middle. This is a height of 4, and so we say the amplitude of this graph is 4. Alternatively, we can also measure the difference between the top and the bottom of the graph, this total height difference, and then divide it by 2.